Hello, this is an example problem for truth tables. Here we have the following compound proposition. It reads, P and Q XOR R or not Q if and only if not Q implies not P. In order to do these problems, I would like to adopt this certain method called the engineer method, which I have coined, seeing as how engineers solve problems. What they do is they first get this entire compound proposition or problem, if you will, and cut it into smaller segments. So what I will do later is I will cut each into small segments. This P and Q will be segment 1, R or not Q will be segment 2, and then this XOR will compare segment 1 and 2. This will make segment 3. And then we will have segment 4, and segment 5 will be a comparison of all segments. Comparison of 3, which is composed of 1 and 2, and 4. And that makes segment 5. So this will be cut into 5 segments. I will now assemble the truth table. As you can see, this is our truth table. Now, hold on, I will mark it first. So this is our truth table. Just like before, we start first with the P, Q, and R truth values. And then since there are items such as not Q and not P, as well as, and just in case not R, we will then include these. Although not R is here, I just included it for demonstration. For demonstration of how a negation works. Supplementing to the not P and the not Q. Anyway. Then after we find the truth values of each individual proposition, that is when we can find the truth values for their compound propositions. And for this one, for number 3 for instance, segment 3, which is segment 1 XOR segment 2, I have chosen not to write it down as it is too large, so I've labeled it as 3 here. And I've done the same with number 5, as it's also the entire compound proposition. Alright, so now let us start. So when trying to do this problem, what's very crucial is inputting the truth values. So first, we have to input in the table according from left to right which appears first. So P appears first, then Q, then R. So we start with P. P will be true, then true, half true, then half false, true, then false, 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 false. Oh yes, and just so I don't leave this out, to know how many combinations that we'll have to make or that will appear from our compound proposition, we have to look at this equation, 2 raised to n, where n is the number of propositions, or here, number of values, which is p, q, and r. So it's 2 raised to 3, which is 8. These are our propositions. If there were only, for instance, if there were only 2 propositions, then we would have to make 4 combinations. It would only reach 1, 2, 3, and 4. So the start would become true, true, false, false, instead of true, 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 false, 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 false. So after we input the truth values of P, then we go to the truth values of Q. And Q goes like this: true, true, false, false, true, true, false, and false. Now for the truth values of R. R will be an alternating, but no longer true, true, false, false. It will just be true, false, true, false, true, false, true, and false. Okay, now that we have our truth values, we can now find the truth values of the negations. We'll start with not P. I will highlight it first. So not P, we will be looking at this. And it looks like this. Not P, so true becomes false, 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 and false for the first 4, and then true, negation of false, true, true, true. Now we will look at not Q. It can be important to highlight what you're looking at, because from afar, these values may look quite confusing, and you can confuse one column for another. It could be quite dangerous if that happens. So not Q, true becomes false, false, true, true, false, false, true, and true. Now we have not R. To make it faster, I think I'm just going to put a bar on top. So R would become false, then true, then false, then true, then false, then true. Now, it's good to check first here if we've made any mistakes before proceeding. So, now that we have prepared our truth values, we can now go to the compound proposition parts. Let's start with P and Q. Now this is where highlighting is very important. P and Q. Then we can compare. So first row, true, true. Remember, it's a conjunction, and if it's a conjunction, it's true only if both statements are true. True, 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 true. True, false is false. Then false because it's false, true. Now we can look at R or not Q. Remember, this time it's disjunction, and in disjunction it is only false if both statements are false. It is true if at least one is true. So we will start with the first row. T's R is true, so that makes it true. See, the next row is false, false, so that makes it false. At least one is not true. True. Now for our next row. Okay. For our next column, this is number 3, which I have labeled as XOR between 1 and 2. So now we have to look at the values of 1 and 2 in order to determine the values of the XOR, the exclusive OR. So for number 3, we'll use exclusive OR. And remember, in exclusive OR, the statement is true if only one of the two statements is true. So only one should be true. If both are true, then it is false. So let's begin. True, true, that's false, because only one has to be true. True, false, that is true. Only one is true, only one is true, only one is true. Both are false, so that makes it false. Only one is true and only one is true. Okay, and now we can proceed to number 4, which is the implication. Remember, in implication, the statement is only false if the first statement is true and the second statement is false. Not Q and not P. Also, if you take a look at this problem, the tricky part is you may confuse the positions of Q and P, because Q in the in the chart, the truth table, is after P, but you have to follow the implication as Q goes before P, so you have to compare Q to P. Starting with the first row, this is true because both are false, so it still satisfies. True. Look at this. In the third row, it's not Q, it implies not P, right? Look at that. It's true the first and then false in the second. That means it's false. The same here, false as well in the fourth row. True in the sixth row though, because it's false true, not true false. Sorry, wait. Yes. The fifth and sixth row are both true. The seventh row is true as well, and so is the eighth row. Okay. Now we go to the final one, where we have to compare 3 and 4 for the biconditional. Remember, in the biconditional, the statement is true if both, for biconditional, it is true if both statements, both propositions, have the same truth value. So they have to have the same truth value. If not, it is false. False, true for the first row, it is false. True, true, that makes it true on the second. False on the third. False on the fourth. True on the fifth because it's true, true. False, true, that makes it false. True, true is true, and true, true for the eighth row is true.